When we talk about anatomy and physiology, oftentimes we talk about fluids in the body, and those could be the fluid compartments include the blood. So our blood has water as its solvent. It dissolves substances and it transports it in solution. So we can specifically call or talk about the blood plasma containing fluid. We also have fluid that surrounds every one of our cells, and this is called interstitial fluid. So this is surrounding these cells. And then we have fluid inside of our cells. So that is called intracellular fluid. So this interstitial, that term has to do with the fact that this is the fluid that's in the tissues. So it's important that our cells are bathed in fluid because we have to have gas and oxygen, like in carbon dioxide, diffusing. They have to be first dissolved in water before they diffuse in, right? And before carbon dioxide diffuses out. And so it's important that our cells are bathed in this fluid. Now, when we look at the intracellular, this is inside the cell. So you can see that term, the intracellular fluid. So these make up what are referred to as the fluid compartments. When we look at the blood plasma and the interstitial fluid, these are extracellular. So sometimes this is abbreviated as ECF. So extracellular would be in the blood plasma and in the interstitial fluid. And then the intracellular is sometimes abbreviated as ICF. The interstitial fluid itself is just IF. So interstitial fluid is IF. So you'll see these abbreviations in your textbook. So what is this electrolyte balance? So remember that in solution, we have solutes. And so solutes are dissolved in water. And some of those solutes have a charge. So when we look at electrolytes, and you hear about this all the time, like for example, when you're talking about exercise, and I feel like I've depleted my electrolytes, right? So I might drink some Gatorade, and that has electrolytes in it. The Gatorade, the electrolytes are primarily salt. So sodium and chloride is an example of an electrolyte. So when we look at these electrolytes, these are charged particles. And so if you put electricity through them, that would travel through these charged particles. So these charged particles sometimes are ions. So they could just be simple atoms that have a charge. So for example, they could be sodium, they could be chloride. A K is actually potassium. So if they are a positive charge, they are said to be an anion. So this is a positive charge. And then if they are a negative, they are said to be a, oops, I did that wrong. This is negative charge. Hopefully somebody caught me on that. That's negative charge. And then the cation is the positive charge. Now, it's important to realize that there are other things besides electrolytes, for example, in your interstitial fluid. So we have non-electrolytes as well dissolved. So non-electrolytes are things that do not carry a charge. And so, for example, this would be like urea. It would be like glucose. It would be lipids. And then creatine is another a non-electrolyte. So those are also in solution. So when we look at the contents of the water, the total water in the body, it actually makes up a quite a bit of weight of mass, right? So the water is important and it has a large mass. So the amount of water changes over a person's lifetime. So the amount of water, which is measured as percent body mass, changes over a person's lifetime. So babies have lots of water. They're almost like just full of water and they're just like bursting with water. So infants are about 73% or more. So infants, 73% plus, right? When we look at adult males, they actually have more water than females. Adult males are about 60% water is their body mass. 60% of their body mass is water. And then the adult female is less. It's about 50%. And one of the reasons for this is that your muscles have more water in them than your fat. So fat, lipids are nonpolar and they repel water. And so when we look at the body weight and the body mass of females, they have more fat. So the reason why we have this difference is that females have more fats, which repels water, and males, the male symbol, males have more muscle, and that has a lot of water in it. Okay, so water will start to decline as you get old. So in old age, people literally are drying out. So it's not just their skin and their hair, they're just drying out. And so in old age, the average 70, 80, 90 is about 45% water. Okay, so that is interesting, I think. The difference and the change in your water content as you change and progress through your life.